This is the data.com website, which is where we got our data from. We uploaded the data we wanted from a different data set on this website, which is called the Twitter user data. Then from in here, we developed a query. This is the function Python code that we created. This first function called data basically just does the query to the data.world website and brings that back this data using the data.world module. And then it returns data as a data frame, which is what we have here. This next function is data calculation. So it basically just takes in the data frame, and then it calculates the likes per time and the tweets per time by converting to date time and then subtracting from the time that the data was collected by the time that the date time that each Twitter account was created, and then dividing the amount of tweets by that time difference and the amount of likes by that time difference. And so it outputs a score for each of them, which is shown right here. This is likes per time, and this is tweets per time. This is the Google Cloud Natural Language API that uploaded a bunch of data points, and it translated them into data. Basically, it determined positivity scores for each of these text values. And then we have the sentiment analysis function. So this is where we ran into a snag, because we realized that the Google Cloud API only will take in 600 data points per minute. And so we have 20,000 data points. So obviously that's going to be a big issue, because if we were going to constantly run this code every time someone was going to use the code to determine their positivity score, then obviously the code would run for hours. So this is where we decided that rather than have a code that runs and pulls from the API every time we run the code, we were going to get all of the sentiment scores from each of these tweets and then create a master CSV file with all of the true data, which we then used for the rest of our coding. So here we have the basically just the code to upload to the sentiment score right here. This is what this is. But this part is a snag that I ran into. Basically break up the 20,000 data points into sets of 500 data points, and then run each 500 data points through this code in sets of 9, because if I did more than 9, which is 4,500 data points in 9 minutes, then it gave an error saying it was too many requests. So we had to do it in segments of 9 and segments of 500. So 4,500 data points each time this ran. And so we just had to manually change the code, loop it over and over again. And so we did it 5 times, and then we wrote them into CSV data files. And then combine and write to CSV file basically takes in all of these CSV files, vertically stacks them on top of each other, and then writes to a new CSV with all of the data, which we used for the rest of the project. Our next function, convert to binary, just takes in this big data file that we have from previous, and it goes through all of the positivity scores. And if it's a negative positivity score, it assigns it a score of 0, and if it's a positive binary score, it assigns it 1. And if the score is exactly neutral, 0, it assigns it a 0.5. The reason why we do this is for a logistic regression to work, it has to be binary scores. The next function and the final function is the heat map function. And the reason why we have this function is to visualize the results of the logistic regression. Okay, so this is our main code. I'm going to run it. It calls the data basically, and then calls the tweets per time, likes per time, adds it in, and drops the neutral values. That's basically all this does. And then right here, this is the actual logistic regression, and it outputs a heat map and a score. So the score right here, 0.56157, is our percent correct. So it got 56% correct. And if we come look at the heat map, we can see kind of why we got this value. The reason why is the code, it never predicted negative. It only predicted positive. And after extensive research, we realized the reason why this wasn't because our code, but the real issue comes from the data set. The initial data set was not enough for a correlation to be drawn, because we only had 2 independent variables, tweets per time and likes per time, and likes per time was not enough for it to draw a conclusion. We really ended up only with 1 real variable, which was tweets per time. And this tweets per time data wasn't enough for the logistic regression to determine basically positive or negative. So it only guessed the majority basically, which is why it has more than 50%. This obviously is not a very good estimate, and we could not improve the logistic regression after all of our research because it was from the data set, not from what we use the data set for.